So yesterday I talked about our membership and that we were currently at 349 members, which is amazing growth over the last 4 years. We've gone from about 150 to about 349. And I'm extremely happy to say that we nailed 350 yesterday. Metro Systems, yes, indeed. Metro Systems out of Laval, Quebec, joined us yesterday on our commercial chapter, and we're extremely pleased to have them aboard, and we're going to help them out with a couple of little extra goodies as they work through the membership process joining us. So really happy to have them aboard, and yeah, 350 members. I would have never thought that that would be the case in such a short time. So speaks volumes to what we're doing and the belief that we're providing good value to the membership. So that's great. So I'd like to open up our first session today. So with us today, after incredible response from her last presentation that she did last year in Toronto, right? Juliette Cook with Half Climate Design. So Juliette is going to talk about, actually, let me step back. Juliette is an intern architect, lecturer, and researcher, and a new mom. And she's got the little guy with her today. I met him. He's looking around going, someday I'll be a glazier. This is amazing. It was really great to see him. So that's fantastic. She brings a life cycle lens to design thinking across diverse portfolio of projects, evaluating these from perspectives of embodied carbon, operational performance, cost, reuse potential, toxicity, labor, and more. Feel strongly that a return to a deeper understanding of materials and the ways that they are made and in the ways in which they go together will enable a more regenerative design. So Juliette, please come on up and join us. It's going to be a great session, so pay attention. She's got some good stuff that she's going to share with us today. I'm going to sit down. Now I just got to find where I put your, somewhere here. Where did I put it? It's right there. Nope. It's right there.
And then is there a mic up here?
A hand mic, I'll give you that. Okay, hang on. Just give me one moment. Again, I'm running a bit slow this morning. I've still got my sea legs on, so it's... You share that or no? There we go. Okay, turn that guy on. And that guy should move it. Yep.
Yeah, I can make it.
Can you, yeah, can you? Perfect. There you go.
Great. Thank you so much. Hello, everyone. Bonjour tout le monde. Unfortunately, unlike our government representatives, I'm not going to be switching in and out of English and French. I'm going to stick to English for today, but I do speak French, although my technical knowledge of some of the terms I'm going to be presenting on is not so high in French. So that being said, I'm so happy to be back after a year. I see some familiar faces. Remember, some great questions from last time, so oh, good. Hopefully I'm prepared today. Also, yes, second day again, so usually people are feeling a little more tired than I'm sure they were on day one. My name is Juliette Cook. Thank you for the introduction, Terry. And yeah, I'm just grateful to be here for a second time after last year, and I'm going to be speaking to sort of life cycle assessment, notions of EPDs or environmental product declarations, and how we use these tools to assess the performance and provenance of windows. Okay, clicker is not, am I going forward, back? Maybe that's just the mouse will work? No? Okay, I'll just do it on the keyboard. Yeah, that's cool.
Now try that.
Oh, now try the clicker. Yep, I just had not turned it on.
So down.
Yeah, okay, great. So I'm going to start with a quote by Lloyd Alter. I'm not sure if you're familiar with him, but 200 years ago, windows were a hardworking, carefully thought out piece of climate control. They were often double hung so that they could be tuned to maximize ventilation. They had shutters for security and privacy while still maintaining ventilation. There might be a sheer drape inside to cut glare and heavy drapes for keeping the heat in the winter. keeping in the heat in the winter. They were tall to let light deep into the room, but they didn't come down too close to the floor. Glass was expensive, and you didn't make the window any bigger than it had to be. And a lot has changed in 200 years. We still are designing some very smart technology, but we also have artificial light and mechanical ventilation. Windows are often treated as a more decorative element in a facade, designed from the outside according to how they look rather than maybe how they work. Speaking from an architect's perspective here. Perhaps, as the saying goes, you can have too much of a good thing, though. And some might argue that windows shouldn't be any larger than they have to be to frame a view. So folks like Monty Paulson, who's quoted here, or Nick Grant would argue that windows have to work for their keep. And why should we care about the functionality of windows? Well, we're in an ongoing climate crisis where we will be experiencing an increasingly hotter world with many risks of overheating. And a building envelope with all its various components plays a critical role in protecting the building occupants. Various publications have been released to guide building design that is healthier and more resilient, like this document released by Pembina Institute earlier this year. Right, next time I need a Brittany mic like you, Terry. And, this document details a bunch of design strategies to provide climate resilience to various core climate change impacts. So here we're looking at extreme heat, and we can see, again, as an architect, this is really informative. I can consider my building shape and massing, my building orientation, the thermal mass of my walls, but then I get into some windows, reducing window to wall ratio, related to windows, exterior or more effective or interior shading. And some other more specific technicalities around window glazing or coatings. And windows represent an enjoyment of the home. They fulfill much more than just physical needs. They must allow sufficient personal control over fresh and cool air, sound, sunlight, street lighting, privacy. Views of the sky are necessary to synchronize our circadian rhythms. Views of trees encourage biophilia. And of course, windows allow for the perfect stream of light to come through the window so your cat can bask in it. This is my cat, my other baby, who is not here today. And designing for climate resilience is an important part of the equation, and part of the equation as well is lowering our carbon emissions. The IPCC, the Intergovernmental Panel on Climate Change, has established 2030 as a critical year at which to chart our progress, needing to cut global emissions by 50% to limit warming to 1.5 degrees. And when we say 50%, 50% of what? In our industries, we're talking about building materials and building operations, where the building materials are roughly 11% for the core and shell, so the structure and the envelope, and then 10% for all other building material manufacturing. And then that 28% belongs to the operational emissions associated with the building. And windows and doors are important to both of these components. And so in recent years and decades, the focus has largely been on operational carbon, the thermal performance of our buildings, what the carbon emissions are from running the building. And more recently, we've sort of exploded that view out to consider the emissions through the whole life cycle of the building and all of its material components. And so here we're seeing, is anyone familiar with whole life carbon, embodied carbon, where the literacy is growing? Great. So A1 to A5, that's all the manufacturing of the raw extraction materials, making it into a product, bringing it to site, putting it into a building. In the use stage, the B stage, which is of particular interest to me talking to a group here, is all the replacement cycles throughout the building, right? When a system fails and we have to go in and replace it. Then we get into the end of use stage. So what happens when the system cannot be, the components can't be replaced. We have to get rid of the whole system. Often we're landfilling, sometimes we're recycling. And then D is benefits beyond the life cycle. That's where we get into reuse, material reuse. And so we can view the life cycle as a graph with number of years along the x-axis. And we can elaborate on that B stage or B phase. So we've got our practical completion in that tall bar at the very left. So that's the embodied carbon. All the red bars here are embodied carbon. So now my building is complete. I'm handing over the keys. My blue bars are the operational energy that we're just assuming is consistent over time. Of course, with a decarbonizing grid, we might see that go down. And often operational carbon contributes more significantly than embodied carbon, but when your grid is a bit greener, we start to see some of that switch around. And so when we get to later in this presentation, that B phase is what I'd like to revisit, or maybe in the Q&A we can talk more about that. And, windows and doors, barring anything interior, make up part of the envelope, the facade of a building. And when we look at just those A phase emissions, it's about 13%, give or take. This is some averages from a couple different buildings. But when we expand to include the B and C stages, that's where we see it go up to contribute almost 40% in this case. And that's really driven by those replacement cycles. It's also driven by the fact that often glazing systems are made up of materials that sit at the top of this material pyramid that tend to be a little more carbon intensive. This is a pyramid out of a Danish institute that if you go onto the website, it's live, and as you input quantities, it auto-generates what's highest carbon. It's pretty cool tool. And of course, there's some drive in the industry to reduce embodied carbon, especially in flat glass, which typically has dominated the carbon of insulating glass units. This is a low carbon flat glass from AGC. Here is a photograph of my business partner, Kelly Doran's cottage in Lake Havelock in Ontario. And, at the time it was built, and what's that? Yeah. It's primary residence. And, at the time, it was written up in Canadian Architect as being a highly sustainable, tightly airtight, building, all the things that my business partner was taught were the most sustainable things to be. And when he got introduced to the concept of embodied carbon, he was like, I might do a little assessment on my own cottage here and see how I did. And so he identified where all the materials were coming from and used EPDs, environmental product declarations, to map carbon data onto the quantities of material that were happening in his cottage. And a really interesting outcome of this was the revelation that our supply chains are quite complex. And this is specifically those big, beautiful windows, all the travel distance that the different components of those windows took. And you can see there that the sealed unit goes past the project site to the fabricator and then right back to the project site. So there's some redundancy in the transport there too. And all that transport comes with carbon emissions as well. So what we know, my company, we're architects, but we are consultants, and we consult on anything sort of sustainability related to the built environment. We do a lot of benchmarking, life cycle assessment for firms where they want to understand how their projects are performing. We take quantities from, usually if they've got a really beautifully modeled BIM model, Revit model, that makes our job a lot easier. And we map the EPD, or the environmental product data, onto those quantities. We then will add, this is envelope specific, but we'll add the structure. Sometimes we go to interiors. More and more, we're looking at MEP systems. And when we look at the envelope, we can create these kind of heat map drawings where very quickly we can see what the relative intensity of carbon is across different systems. And where the darker colors are is typically glazing systems. And so this kind of assessment and the visualization has encouraged us to interrogate the glazing requirements specifically here for the ground floor commercial spaces, which are often just floor to ceiling glass. Could the height be reduced, for example? Could we reduce the total area of glazing? And by repeating this process for every LCA project we do, we are compiling a larger database of varied envelope systems. We have found that the consistent finding is that the glazing systems tend to be where the carbon lies a little bit higher, and often in that ground floor commercial. This is not to just, pardon my French, shit on everyone. I'm saying this is the opportunity, right? There's an opportunity here. And of course, when we consider the embodied carbon, it's really critical to consider the operational performance of these systems as well. And so these, project-specific studies that we've done are very informative to our clients. They're informative to us. Recently, we were engaged by the City of Toronto to look at their own urban design guidelines, which have various, they were written 30 years ago, and we sort of said, what are the unintended consequences of these guidelines? Are they inadvertently causing higher amounts of carbon in our buildings? So we looked at 10 projects, 3 low-rise, 4 mid-rise, 3 high-rise. You can see there on the screen. And again, we did our little heat map trick. Across all projects, the highest contributor on average to the embodied carbon in building facades were the windows and glazing systems. We viewed across the whole life of projects, this factor can double or triple depending on the expected service life of the system. So that's when we get into that B phase. How long are we assuming the system is going to exist for? Are we actually maintaining it as it should be? Windows and glazing were found to be the locations of greatest thermal heat loss and solar heat gain, the greatest contributors to operational emissions. And the facade of a building, as we saw before, can account for anywhere from 15% when we're just looking at those initial emissions to up to 40% when we consider the B and C phases. And so while, one of the significant factors that influences why these are more carbon-intensive parts of the building is the overall window-to-wall ratio. A lot of these towers had no opaque systems other than the shadow box that was part of the window-to-wall or the window wall. And so a higher window-to-wall ratio, can offer benefits like we talked about just before, like daylighting and views. But as I mentioned, they also typically result in a higher demand for heating and cooling. These glazing systems we've found in the conversations we've had, and this is something I'd love to hear from the experts here, hold a greater need for maintenance and replacement over time. And so looking at the maps here, buildings like low 1, low 2, and mid 4 performed better in terms of their facades because their window-to-wall ratio are roughly 25 to 30%, whereas tall 3 was entirely wrapped in curtain wall. That's the one at the very right-hand side of the slide, causing its facade system to be the most carbon intensive. And when we break down all the systems by material components, what we're seeing here is all the opaque wall systems are on the sort of left side of the slide. And as we move throughout the slide, the last 3 bars are the glazing systems there. And, I do want to pause. The gray bar at the top there is where we're seeing that B, the replacement cycle. So just the colored parts at the bottom are where we're seeing those A1 to A5 emissions, all the raw extraction of material, manufacturing, and installation in the building. And what's really critical for what I do for a living is that there is a serious lack of data to do this kind of analysis. We have some product-specific EPDs that we can use and rely on, but not a ton, right? So to make my job easier, it would be great if everyone here who works for a window company to kind of, apply a little pressure on that side, because it would just make the data more reliable, really, at the end of the day. Before we even had whole window system EPDs, I had to sit there and I would model out an entire frame, get the volume, get my glass, get a volume, and I'd build my window system myself using EPDs for each of those components. So we're moving, but it's still not there yet. Okay. So that's we know this. We've been doing LCAs. We're repeating the process. We kind of have a consistent finding. What can we do about it? Number 1, optimize window-to-wall ratio. That's what I was just talking about. This is the Interdisciplinary Biomedical Research Building by Hawkins Brown from 2021. And what I like about this building is that they still have the impact of glazing, right? You're still getting a lot of daylighting in, you're getting views. But what they've done is they've switched with a metal panel opaque wall throughout. And you can see that it's a little more open on one side of the building, and then progressively towards the right side of the slide, it becomes more and more opaque where the views are not as important. And so optimizing the window-to-wall ratio will help to reduce both the operational and the embodied carbon emissions. And these are both key ingredients in creating a more sustainable facade design and performance. In one of the projects we looked at that not allowed to share with you, but it's a very large and entirely glazed project, university facility in the US. And we did exactly that. We said, what if instead of the shadow box, we replaced every instance of shadow box with a steel stud wall insulation and a metal panel? And we saw a pretty significant drop there, 76% reduction. Now, there are holes you can poke in this assessment. How do you, the whole frame went everywhere. We didn't totally get everything 100% there, but it was a good gut check to see, well, if they had designed windows where windows had to be, and then opaque wall where opaque wall could go, what would that mean for emissions? And, where in the building do we want larger areas of glazing versus areas where we can have smaller windows? How does climate influence how much glazing we design for? how do we rethink the current dominant ways of designing to prioritize more specific views? Pietri Architect in Aubervilliers, France, put a picture frame around the smaller windows. So they needed the smaller windows to hit a certain energy performance, but they wanted them to still appear bigger. And so they did this nice little kind of wood framing inset window. And I just like this image because it's showing you the kind of new multi-unit residential build on the left with windows that are almost the same size as the older building that it's adjoining on the right-hand side. Number 2 is we can design for wellness and resilience. So, climate change, that's what I kind of started my talk with. And I think that that is the big umbrella thing looming over us, the big cloud looming over us. I mentioned physiological needs, apologies. So the balancing of circadian rhythms, having visual contact with external environments, having operable windows to refresh indoor air and maintain good air quality, reduce summer discomfort if you don't have AC, for example. This is an image from a Maggie Center, which is a cancer treatment center in the UK. They have them all across the UK. And so we're still seeing pretty tall glazing, but we're not seeing it wrap the entire building. In France, I was born and raised there, so there's a couple France shout-outs here. I'm a little biased. But I also just found this out while I was preparing for today. Since January 2022, there's a new environmental regulation, RE 2020, and it has requirements to reduce energy consumption, reduce the life cycle carbon, and address occupants' thermal comfort in summer for non-air conditioned buildings. Because a few years ago, when we had a huge heat wave there, a lot of people died. And that's something that we'll face in all countries. And so they developed the metric degree hour of discomfort, DH. And this must now be considered in the design to limit discomfort during periods of high heat and to avoid the widespread use of mechanical cooling, but with systems in place to require a minimum amount of glazing as well. They usually say 1/6 of the facade has to be glazing. And my company is currently working on, are folks familiar with the Canada Mortgage CMHC Housing Corporation? Yeah, right. So we're working on the new catalog, which is all focused on infill development. And we were just in Ottawa last week and we're meeting and they handed around all these old catalogs. And the big difference that I noticed between the old catalogs and how we're designing new buildings is a lot more overhangs and shading devices in the old ones. Shutters, overhangs. These are all things, design features that protect the facade, right? That provide shading. So we're really interested as we're engaged on this project to see some of these get baked back into the future catalog. And how a climate sensitive site layout and building design, including fenestration, but also these shading devices and then things like natural ventilation offer the possibility to reduce our use of electricity, use for indoor residential lighting, and as well as reducing heating and cooling demands. This is another lovely little UK-based multi-unit residential building that has operable windows, natural ventilation. And these will be key for more passive survivability, as well as a post-pandemic indoor air quality. It's typically of concern, balconies and having windows that can open in the projects that allow for it, as well as the size and a position of windows that are dictated by views and daylight. Next, we come to considering whole life carbon. And I've got 2 images here, one of a building in Calgary and one of a building in Toronto. And these are both coined as high performance buildings. And it's really crucial to understand, I'm here coming from the embodied carbon lens, and I realize there's a whole other piece to the puzzle. It's really important to consider these things not in opposition, but as where the synergies are. And for these 2 high performance buildings that we just saw, one sees about a 50-50 split between embodied carbon and operational carbon in the year 2030. So in my Calgary building, year 2030, it's about 48% is embodied carbon. That's really due to the grid distribution of Alberta, which 89% of electricity is from fossil fuels. And then when we look at Ontario's grid, which is much cleaner, 34% nuclear, 28% natural gas, about 22% hydro, indicates that the embodied carbon proportion of the whole carbon component remains disproportionately high throughout the life cycle. And if you were at my talk last year, did you want to take a photo? I can go back. You also can get access to the slides if not already, but all right. If you were at my talk last year, I went over a study that we did that looked at 4 envelope systems, 2 residential projects that you're seeing on the left, 2 commercial that you're seeing on the right. And we wanted to understand the kind of synergies between the operational and the embodied carbon. So we tracked things like U value, the embodied carbon of the materials broken down here on this slide. And right away, again, the larger chunks are on all these bars. If you look over to the legend, are the glazing systems. In 2 of the windows, which were window 1, which is a brick-clad wall with PVC frame double glaze unit. Wall 2 is an aluminum frame double glaze window wall. We're seeing a significant jump in terms of the carbon emissions between each system, right? Where the first one, we've got some opaque wall, there's better window to wall ratio, there's more thermal insulation, versus the second system, which is performing at 146 kilograms of CO2 equivalent per square meter at year 2030, our critical year. So we're, not quite double, but almost double what the brick wall is performing at. And so when we take all 4 walls and we just look at their whole life carbon, again, we can start to make more meaningful comparisons across these different envelope systems. The emissions profiles that have the slight jogs, this is where we're seeing that material replacement come into effect. Here we're looking at a comparison of 2 curtain wall systems for an office building in Victoria. This office building, fun fact, had some quadruple glaze systems that when we met with the design team, they said, yeah, we didn't actually need them to be quadruple glaze. And we're like, well, okay, great. But it was already in construction, so we couldn't get them to change their minds on that. But based on current BC grid and electrical heating and cooling, the main takeaway here is that the whole life never crosses. So based on the regional grid intensity and the worst case scenario of no decarbonization of the grid, the crossover year between the double and triple pane systems is 2068, far beyond our 2030 or the 2050 mark. And so as a company, we're interested in doing a bit of a deeper dive into this. We understand that when you make this switch, yeah, you can say maybe there's a reduction in embodied carbon. There might be a reduction in the cost. We're tracking the operational carbon, but what we're not tracking in this study is any uptick in mechanical systems that might be required. And that's a big component to this, right? Mechanical systems are carbon intensive as well. So that's the sort of next big step from our perspective in terms of what we want to understand more in depth. And in thinking about grid distribution, but also climate zones, a building's geography has significant influence over what envelope system is appropriate, per what we just went over. So maybe triple glazing makes a ton of sense in one province or state, but not so much in another. What would be the case in Toronto, Calgary, LA, Miami? And then when you layer on the climate resilience piece, it gets slightly more complicated because we're designing for that as well. And so we graphed it. We said, what's the crossover year in each of these places? And so we're seeing that in some, Minneapolis, 2030, okay, maybe triple glazing makes a lot of sense there. But you're seeing Toronto is not even on the graph. We're over in 2147. So maybe dual pane is okay there. All right, now the topic I'm really excited about hearing from everyone here is planning for maintenance and durability. And so when you consider the whole life carbon and not just the upfront carbon, those A stage emissions, we have to really understand what's happening in the B phase. And I realize that's a lot of projection. It's based on a lot of assumptions. And that's what we're going off of. We're going off of what an EPD tells us, how long something will last. We're going off of what a contractor tells us is happening in the building. I'll just recall this graph quickly just so we understand. We're, on the one hand, we've got the A emissions, so around 13%, but when we expand, we've got all those replacement cycles that contribute. And so ideally, glass replacement would be easier, aka quicker. For glass, within buildings, there's an escalation of size and geometrical complexity. Lots of within project variation. I know I've looked at these drawings. It's like a zillion types of windows. I don't know how you feel. I'd love for it to be simplified. And then there's a really supply chain complexity that we saw sort of with that map that we were looking at earlier with all this international sourcing. And if we consider future weather events, all of these present challenges, more challenges for rapid replacement. And so on this service life assumptions, how do we bake that into our models? Now, option one would be that the entire system, let's say the frame and the glass, gets replaced at 35 years. And that's often been what we do because we've heard from various people who build the buildings that rather than go in and repair the sealants and the gaskets and replace the glass, they're not doing that. They let the system fail and then they have to replace the whole thing. So that's where we're seeing the really significant spikes in carbon. But we have done some projects where they've been a little more thoughtful about the maintenance plan, and the frame is to remain, and all they're going to do is go in and change the IGU gaskets and sealants. And so then we break it apart and we say, okay, well, some of these components are going to last the shorter amount. We'll see a smaller spike, but the frame will last the whole service life of the building, which we often assume at 60 years. And so what that means when we bring it back to this whole life carbon graph is we've got our big bar, the main emissions are most often in that A phase anyway. But then at that year 35, that option A, where the whole system gets replaced, would be a bigger bar. That option B, where only the glass and the sealants and gaskets are replaced, is much smaller. So right there is a really clear opportunity for reducing our carbon emissions. And I'd love to hear more about that piece from all of you too. And I like to end on where I hope to see this industry going a little more is embracing circular methods. I'll start by speaking about the Empire State Building. In August 2006, they went through a retrofit, and they planned a whole complete redevelopment of the building to make it one of the most energy efficient buildings in New York City. And it was through a combination of 8 energy efficiency projects, which included a retrofit, I think it was 6,500 windows across the whole building. And importantly, the reuse of 96% of the original frames and glassware to achieve this retrofit. And so thinking through the various materials of these components, the frame systems, we've got fiberglass, we have some wood, we have some PVC, we have some aluminum, and how each of these facilitates or hinders potential reuse and recycling. It's not about saying, no, we can't ever use that. It's just what are the options for making it more sustainable in each of those buckets. And there are tools that exist to assess the circularity of these systems. This is one from One Click LCA, where on the one hand, you're testing how much circular input there is, so how much recycled content is going into the system. And at the bottom of that circle, where the colors are coming out of the diagram, is its ability to be deconstructed and reused. And so how that looks when we kind of scale that up to a portion of a facade, we can use the same tool. And, again, based on some assumptions, we say most of these components are going to go, we're virgin materials, they're non-renewable, right? So a low score as we head in, not a ton of circular materials heading into the system. What we're returning is also pretty low. Most of it's going towards disposal at 65%. Some of it is going to recycling. And how we might move this towards a more circular world, right? So we're seeing more circular components coming in, less virgin material, more reused components, more recycled content in our components. And then on the outside as well, how are we able to take these systems apart to reuse a glass panel as a glass panel or a frame as a frame? And, I spoke about AGC before. I have no affiliation to AGC, but we've had a meeting with them recently and they were speaking about some of the work they're doing. How you might achieve some of this, right? Keeping cullet is extremely clean. Keeping it clean is more efficient than having to clean dirty cullet. And embracing the waste hierarchy pyramid. So where we're reducing at the top here, reducing building new, we go to reuse, we go to recycle, recovery, and at the very bottom of the pyramid, which is our least preferred option, is landfilling. And, this is perhaps more tongue-in-cheek, but maybe one day we take the whole window and just stick it in a facade like so. And this becomes interesting because this is pretty much in direct conflict with energy performance these days. This would not necessarily meet code in a Canadian climate. So I just have some concluding thoughts. I'm going to start with a bit more of a poetic ending, and then we'll get into a bit more of the technical stuff. But as I mentioned at the beginning of this, windows have significant social and physiological benefits. They connect occupants with the natural environment. They provide daylight, they provide views, they improve mood, reduce stress, and enhance overall well-being. And windows are often featured in artwork. This isn't a piece by Faith Ringgold. And just like the diagram that AGC had in their slides, we often rely in the LCA world on this hierarchy of mitigation, where there's potential for impact reductions that scale down from the building nothing band all the way down to building with lower carbon materials. And so the impacts that all building materials can have can sit somewhere in this or across this, right? It can be about using less material. It can be about using lower carbon materials. It can be about building for sufficiency, right? Do you need tons of windows or smaller windows? And I'm just going to end with another quote by Lloyd Alter. You know, windows are complex. They're carbon intensive. They are often expensive. We're dealing with that on the CMHC catalog right now. Too often, from the architect's side, they're designed for aesthetics. And so really it's about working together to sort of redefine what the aesthetics of our buildings are and, drive a revolution in Lloyd Alter's words, which might be a tall order, as he says, but decarbonizing each component of society will take nothing short of a revolution. And that's all from me, and I look forward to our Q&A.
Good morning. Thanks for the presentation. So I'm Raymond Roy with Guardian Glass. So actually I was on that project, Empire State Building, and actually doing the retrofit of all the glazing for, as you say, 5500. One thing that was unique about that, and to your point about retrofit in the sash, a couple things. Longevity of the IGU. You know, we're seeing, the envelope being pushed, or that the IGU life expectancy, like with VIG. I think that's very, positive looking, right? Because we're far beyond what you'd anticipate with IGCC or IGMA, or think of that nature, 20 to 30 years. Maybe the life expectancy, as you're saying, maybe 60 years. Maybe we may have some, potential there, right? Where the service life of the IGU matches the frame. The other part is the retrofit, in which, Terry, maybe you can chime in on this, but on that particular project, the Empire State Building, it happened to be a mechanical aluminum window. So with a gasket. So basically you could unscrew it, pull it apart, replace a gasket, put it back in. On other projects such as, wet glazed or structural silicone glaze, I think that this would be a little bit more of a challenge because you have a lot more destruction, a little more challenge. So having it easily to change out that component, I think that would be key if you're just talking about IG replacement.
Well, thank you for those comments. This was not a plant. It's not like I invited someone I knew worked on the retrofit, and I just learned a whole bunch from you just there. But I think what you just ended on holds true for all building systems. Like for design for disassembly, we always say prefer mechanical fasteners, try not to use things that are laminated as much as possible so that you are able to recover things more easily. So, yeah.
My name is John Glenn. I'm from Cardinal Glass, full disclosure. Have you ever tried to model a building given the stated warranty on the glazing system? So like if the glass has a 10-year warranty, which is super common, count the carbon that you're going to have to replace it in a shorter time versus something that's 20 years, for the warranty.
Of the projects I've worked on specifically, the lowest we've gone is 20 years for replacement per what the environmental product declaration says the warranty is. So I have never come across 10, but that probably just means that there's not the data in the softwares that we're using to inform us to go with 10. That being said, it is just a parameter we can change. So if I get invited for a third year, I'll do the study and I'll present it next year. But essentially all you would see is on that bar graph where you're seeing over time, you would just see an uptick every 10 years. And so something like paint is something that gets, you typically assume 10 years for paint. You see a little spike there throughout the service life.
And my second question is when you do, when you have the high solar heat gain or low solar heat gain and you get to downsize the equipment, if you're replacing less expensive equipment because it's downsized, does that help your carbon assessment or long-term energy?
Yeah, if you're doing a whole building carbon assessment and the equipment is getting downsized, definitely. has the system failed? Could it be repaired? And, if it's made already, the kind of more sustainable thing would be to leave it in place. But the second comparison would be replacing it with the exact same system or downsizing, and downsizing would be more sustainable.
So I wanted to add a quick comment to this. Having gone through the EPD LCA process with a window and door manufacturer, the ISO standard when you're going through the EPD calls out the warranty life for those components as your replacement period. So you actually have to put that in as part of your LCA process.
Yeah, which is probably, so we don't do the actual LCA of the products. We take the product LCAs that are done, which we refer to as environmental product declarations, which are sort of like the Sparks notes of an LCA for a product. And then we take all those Spark notes LCAs for all the material components of a building and sum them together and get the whole building. So we're less involved in going around factories and actually understanding each part of the process. We read the reports based on someone else who has done that.
So I always enjoy listening to a presentation, and when you're following along, and you might drift in and out a couple of times, and all of a sudden you hear quad glazing in Victoria. What? So I'm wondering, are you seeing that scenario where we push into performance buildings, et cetera, and designers are coming up with, I've got the best design, I've got the best building, where we're running into situations like quad glazing in Victoria? I can't imagine anybody that thinks that makes sense from a carbon content, from a sustainability. I just don't get it. And is that becoming more common where you see decisions being made that aren't evaluating all of the parameters?
I mean, I'd like to think that the tides are changing and that people are, that we got a lot of hands that knew what I was talking about today. And I think in the design world, it's the same thing. Architects are becoming more comfortable with these ideas. I think they felt very sheepish when we got to the point of looking through the drawings, and we just were like, we just want to confirm this is quad glazing here. And they're like, yeah. And they knew what we were going to say. Like, why? You're Victoria.
Why?
And they agreed. That building would have been fine with double glazing. But we didn't do a climate resiliency piece, and that's where triple glazing, still has a ton of value. But from a grid perspective, the building would have hit the tier it was going for with double glazing in a lot of that building. So I think that we're seeing more and more conscious decisions that are taking into account all of the pieces. But like I said, I think the big question mark still is mechanical systems. And when you say, oh, replace your triple glaze with double glaze, it's not quite as simple as that. You have to understand what the impacts are to the rest of the performance of the building and account for that in the methodology. And if I think there's a limited number of window EPDs, there's an even more limited number of mechanical system EPDs. So it's growing. And so we're able to kind of at least do some initial studies to understand. Mechanical usually accounts for roughly 20 to 30% of the total footprint of a building. So it's pretty significant. It's kind of similar to the facade.
So you're confident better choices are coming?
I'd like to think so. There might be a bit of a moving backwards before we move forwards, but hey,
I'm not cynical.
Designers are hopeful people, so we.
In fact, you have to say that.
I'm not cynical. I just see those kinds of decisions being made, and you just go, what are we doing? Anyway.
Yeah, no, I hear you.
Hi, I'm going to be honest, and I'm going to say that it's very confusing for me and maybe some other people in the room when we talk about energy efficiency versus carbon imprint. And really, I'm at a loss often in this type of situation, as well as the architects that call us. For example, we're in the aluminum works, so we have mechanical assembly, and that's always something that we push forward, saying, you can have a long life for your product. But on the other side, often the products we have a bad reputation on energy efficiency. So it's very hard to know where to stand and where the future is going to be. And also a lot of people, you talked about triple glazing, and I thought that was super interesting between, when you were looking where it would be really necessary. Mm-hmm. A lot of our customers are going for the triple glazing, but a lot of the architects are looking at us and are saying, is it really worth it? because there's not that much and it's so much more expensive. And how much are we going to save? For example, in Quebec with the cost of electricity and it's clean energy.
Yeah.
So, and I have no idea what to tell them. So is there like a 1-800 phone line they can call? Because honestly, it's
yeah.
very confusing.
I can
I-
give you my cell phone number if you want.
Yeah.
But I don't answer
Give-
at all
give to
hours
the
of the
whole
night.
crowd.
Yeah,
See
yeah,
what
yeah.
happens.
Well, it
Yeah.
was just my email, I think, on the screen. I think I keep my cell phone number private. But no, I think both great points. I'll maybe start on the last and then move to the prior one. But where the CMHC catalog we're working on right now, Quebec, I think, is going to propose double glaze, but we're going to have an option where maybe in a certain climate zone you would want to go for triple glaze. And with the conversation of double or triple glaze, there's a whole piece to it where there are certain rebates that exist for homeowners that incentivize going for one or the other, right? And in that sense, there is a bit of a case by case analysis that is somewhat required. And again, it's important to consider that the grid for sure might mean that your performance target will be hit with double glaze. But when we think about, okay, what are the other benefits of triple glazing? Keeping cold out in a power outage, keeping the heat out in a power outage, then it becomes a little bit more complicated and not quite as straightforward as double glazing will be sufficient. I think she has a follow-up question before I address the first part.
Just on the triple glazing, like we used to like you were saying, incentives push us to go to triple glazing. So often it's the incentive that's organized by different organization that pushes us that. So even if we tell them it's not required and they're going to be very comfortable, the institutions around that ask, for the performances require it. So
Yeah.
how do you work with these different organizations without naming them?
We try to work with decision makers. We work currently with municipalities, but I mean, it's really interesting what you're bringing up. I think that where we have seen some friction is, say you're doing a retrofit, and if you wanted to meet the energy code, you'd have to put triple glazed windows in, but you could get almost to the same performance if you just insulated the building differently and you didn't spend the money and all the materials to do the triple glazed windows. I feel like the code should be relaxed in some cases where, you could achieve almost the performance, right? But we're coming off of 30 years of operational energy, like the thermal performance, the energy efficiency being the main focus. And the embodied side is newer. And so we're sort of having to, like, my building science courses in my degree all taught me triple glaze, XPS insulation on the outside of the building. And then I met this guy, Kelly Doran, who was like, no. And it really, it's not about saying no, it's none of that. And it's not about saying no, it's none of these materials. It's about how we're understanding the two together. So to your first point, the energy efficiency is what we have focused on. And so people tend to be very comfortable with that. They understand it. It's what our standards and guides ask us to design to. And we're starting to see the other side also come into effect in policy. And Denmark has just come out with a whole life carbon metric where they're considering not embodied and operational efficiency as separate. They're putting into one metric, and however you get there, you get there. It's a kilogram of CO2 equivalent per square meter per year that you have to hit. And doesn't matter. You could do triple glaze and a different opaque wall, or you could do double glaze and a different, So I think that provides some freedom with what is more important for your specific location, your specific geography, your grid distribution, and so on and so forth. And we're just not there yet, right? We're still kind of developing the understanding of the other piece of the puzzle, which is the materials. And yeah, you're right. Aluminum lasts, and when it's mechanical systems, per the retrofit conversation, you can take it apart at the end of life, and that has a ton of benefit from the embodied side.
So just to add a little bit to this, there's roughly, and it depends on who you talk to, 13 different characteristics, performance characteristics that a window has to meet. And one of the critical errors we have in our code at the moment is that when you design, especially a non-Part 9 building, you have to meet all of them that are specified. There is no relaxation.
Yeah.
You have to manage to hit your acoustics and your structural performance and your thermal performance and in time your carbon performance.
Yep.
And so it is always going to be a difficulty. And until we find a way, in my personal opinion, to allow the architects to make, call it weighted decisions on what is important for their building, this problem will continue to be fairly severe for our industry.
And I mean, it's like I feel somewhat equipped because I do this for a living, and I know design firms that we've worked with would also be able to answer the question, I think, pretty confidently. But even the design industry is learning all of this too. So I agree. I think it's going to be a bit of a point of tension for a little bit longer.
Hi. So full disclosure, my company has started doing LCA analysis and EPDs for window and door products
Awesome.
exclusively. One of the challenges that why we jumped into it is because when we would see what was coming out, there was different standards and you couldn't necessarily compare everything. So my question is, when you're getting EPDs, are they always converted to the Tracy or North American models, or are you just taking whatever data that can come? Because it kind of makes it difficult to ensure that everyone is playing
to
the
the same standard.
Yeah.
Yeah, no, great question. So for some context on that, when you do an LCA, there's kind of a European standard or guide to follow in developing an environmental product declaration. And then there's a North American one, that's the Tracy and CML. So the windows we use for our North American assessments are all under the Tracy.
Awesome.
So that we can have that level of comparison, really. That being said, we sometimes will look at CML, like the European database, because it just something doesn't exist. And this goes beyond windows and doors and envelope systems. A lot of finishes, like interior finishes, there are not tons of EPDs in North America just yet. So we just look to Europe to understand, kind of, again, gut check. And what is neat about the tool that we use is you can actually adjust it's called localization factor, and it applies some sort of math in the background to assume that the product was made on a North American grid based on the geography that you're in.
Okay.
So it's not perfect. It's not perfect science at all, but at least it gets you a little bit, if you're making something in Nebraska that's entirely coal and, much dirtier grid than Ontario or Quebec,
Sure.
It'll adjust for that.
Sure. Then second question, that 35 kind of surfaceability replacement, is that applied universally versus over all like product types or residential, commercial?
So that's a great question. The 35 is pretty typical of all types.
Okay.
Curtain wall, maybe, and that's where the question of, is it the frame or the IG, what gets changed? And but we'll see often institutional buildings, the one where the architect said to us, no, we have this maintenance plan. It's an institutional building. The idea is that it'll be there for many, many years. And so they really thought out how to keep the frame in place and just replace the components inside. So that's where we're able to say, okay, the frame will last this long. Once you move past, the building being constructed, though, it's all sort of made up.
I totally get it.
But I think sometimes I've seen studies where the residential windows will be at a 30-year, but we kind of keep it 35 just for consistency.
Yeah. So my last question, I'm sorry.
That's okay.
In the case, you had that map where look, everything came from all over the world. And one of the advantages of being a carbon or environmentally conscious country is we don't do disadvantage probably. We don't manufacture here, and we offload manufacturing of raw materials to places that don't have the same environmental protections, and we get to play the game that, well, look how great Canada is.
Right.
We're not essentially using Canadian aluminum to build Canadian product. And is there a conversation that it's having at a government level, or that can be had at a government level? It's like, you may have to have smart carbon usage rather than zero carbon, because we will do bad by manufacturing some of our own raw materials, but over this embodied carbon view, it's actually more beneficial for the overall
Mhm.
project and what we're actually constructing here. Because that I think is the worst thing. Aluminum's an open market; it's a commodity, right?
Yeah.
And we get to be blind and oh well, that's their problem. And
Right.
just-
And so are you suggesting that we do create more local?
well, I just to have a conversation or a
Yeah,
study
yeah.
about it of like, we're doing a bad thing,
Mhm.
but we're doing it in a province that energy is nuclear or whatever.
Yeah.
And so we recognize we're taking on carbon, but we're offsetting it
Of course.
by how we're
Yep.
over the
No, and I mean, I think it holds true for the windows and doors and their kind of material makeup. Brick, I found out recently, Quebec doesn't have any brick manufacturing plants, which, correct me if I'm wrong for the Quebecois people here. It's like, let's build a manufacturing plant for brick because the grid's so, because brick coming from, again, Nebraska or Arkansas, which happens all the time in projects in Toronto because they have prettier bricks. That's the quote from the architect. On a coal-fired grid, right? But I think the map I show isn't to say, oh, we can't source anything from anywhere else. It's more to be thinking about the grids of the places where
Sure.
you're sourcing from. And yeah, if we are making things in Canada that are on a cleaner grid, I mean, steel out of Hamilton, they've got some very low carbon steel coming out of there. So I would say for sure bringing manufacturing back. That my business partner always jokes that would be his political platform if
sure.
you know.
Like let's get float glass in Canada. Well, we can't do that because it's bad.
Yeah.
Like we're not having that conversation. So
Yeah, no, I mean, we engage a lot with, so far it's been a lot of municipalities, that level of government, more and more a bit the federal level. So follow up, we can have a larger conversation with some of our contacts.
Yeah.
So,
As-
so just
Sorry, go ahead.
So just to expand on the triple pane, the quad pane, and this young lady, talking about being forced towards triple pane, and you do have to ask questions. So I do applications engineering for glazing throughout the day, right? And that's my first question: do they need it, right? Do they need it on is there a big benefit, energy savings, et cetera? But also keeping in mind that there's other softer benefits too, like occupant comfort. Sure, you may, energy-wise, it may be different, but, you may have, you gain some area, where you can be more comfortable next to the window. Also sound attenuation, things of that nature. So there are other reasons as you retrofit, even thinking about laminated glass. You're like, well, you're doing that, for sound attenuation, but also there's security and things of that nature. So as you go into the glazing, it can be complex, but other the benefits too, because you're looking, even if you're retrofitting, there's a low E, versus, so you're really not going to see a big benefit going from an old low E glass to a newer low E glass, maybe another layer of silver, but diminishing returns, right? So,
Right.
and I've often advocated towards, even I know Cardinal, they have a comfort calculator, things of that nature. So that's that's part of the lead part too, is being able to be comfortable in your environment. So there's some other benefits beyond just only energy, right? And carbon reduction.
Oh, completely.
Yeah.
No, I hear you entirely. And I think disclaimer in all our reports is that we kind of focus on the carbon and always have a few sentences about all these other benefits. And again, it relates a bit back to the whole idea of climate resilience, because in these power outages, triple glaze is going to perform well and keep us safe. So it's not to say it's never an option. It's just with each project that you're working on to not just assume this is the blanket solution.
So
The government should probably take note as the window industry is being faced with more and more challenges to efficiency and energy efficiency. And listening to Jennifer talking about aluminum and where the aluminum is coming from, for me, and I rant about this probably far too often, but I watch coal trains going out of the West Coast with millions and millions and millions of tons of coal going offshore to smelt aluminum to ship it back to us. For an industry that's being challenged like we're being challenged right now, that's a pretty frustrating situation. So anyway, yeah. All right.
So just a couple notes before we wrap up. First off, thank you very much for bringing up Monty Paulson. But for those that didn't know Monty, he passed away earlier this year. He was a bit of a pillar in our passive house community. So
Very well
Yeah,
recognized, respected in this field for sure.
And then you had mentioned some of the passive cooling measures in your presentation. I'm happy to say at the national side, the NRC is taking on a passive cooling research project in order to validate some of the information that we're looking at in the next version of the code. So that is coming, which is personally very exciting to see. And then we have, as Fenestration Canada, been participating in a vinyl window recycling pilot program. So that is in the background, just so you know.
Love to hear it. I was just at NRC and they walked us through some of their test buildings, so it might have been one of the ongoing tests there.
All right. Well, Juliette, that's twice.
Twice.
Should we bring her back, do you think? All right.
I have to. I promised him a study.
There you go. All right. Thanks a lot. Appreciate it.